let's look at a problem based on the concepts we have just discussed. Okay, so we have two angles, theta and phi. We have two tangents, pt1 and pt2. And the problem says, prove that theta and phi are supplementary. Well, a very easy problem. First concept is pt1OT2 is a quadrilateral. Okay, so pt1OT2 is a quadrilateral. So once you have a quadrilateral, you must know that the sum of all the angles in a quadrilateral is 360. Okay, now this angle is 90 and this angle is 90 because tangent is perpendicular to the radius at the point of tangency. So we'll say angle pt1O is equal to angle pt2O is equal to 90 since tangent is perpendicular to radius. Now the sum of all the angles in a quadrilateral is 360, right? Since angle P plus angle T1 plus angle T2 plus angle O in quadrilateral PT1OT2 is 360. Therefore, angle P plus angle T1 plus angle T2 plus angle O is equal to 360. Now angle T1 angle T2 is 90 and 90. So angle P plus 90 degrees, of course, plus angle O is 360. Therefore, angle P plus angle O is equal to 360 minus 180, which is 180. Now angle P is theta and angle O is phi. This is called theta, this is called phi. These are Greek alphabets. So this is equal to 80. So we have proved that theta and phi are supplementary. Now before we go further, let us discuss why the sum of all the angles in a quadrilateral is 360. It's a very simple and a very nice concept. Now let's start with a quadrilateral. So a general quadrilateral with no special properties here. So this is a general quadrilateral with no special properties. Now you can see that it can be divided into two triangles, right? Now if I take this angle plus this angle plus this angle, I'll get 180. And if I take this angle plus this angle plus this angle, I'll get 180 again. And if you look at all the angles that I have marked, they are nothing but the internal angles of the quadrilateral. Therefore, clearly the sum of all the angles in a quadrilateral is going to be 360. This concept can be extended to any polygon of any number of sides. Let me show you. Suppose we have, say, a hexagon. And I'm not saying it's a regular hexagon. Regular hexagon means all the sides are equal. I'm not saying that it's all the sides are equal. Okay, so it's a general hexagon. Now start from any one point, let's say this point, and leave one vertex, join the other. You get one triangle, another. Now if you see this, you get 4 non-overlapping triangles. What did I do? I took a vertex, left one of them, and then from the next one I started joining, because if I join the next one I'll just get a straight line, right? So I leave this particular vertex and join all the other from this point. 1, 2, 3, 4. 1 to 3 basic lines and 4 different triangles. Now again, if you take this angle, this angle, this angle, you get 180. This angle, this angle, this angle, you get 180. This angle, this angle, this angle, 180. These three again, 180. And if you look at all the angles chosen, you get all the internal angles of the hexagon. So the sum of, see, this symbol means sum of. So sum of all the internal angles becomes 4 into 180. Okay, which happens to be 720. Now what if instead of 6 you had n sides? So let us now see what happens if we just take a general polygon with n sides. So far we have taken what? Quadrilateral and a hexagon. Now let's just take a general polygon which has n sides. Okay, so I'll just draw some of its sides, and it has so many different sides. Let's say these are just some of its sides. So now what happens is, if you leave these two sides, if you leave one vertex, what happens? You leave two sides. And then after that, for every vertex, let's say we start from here, we get 1, then go here, then go here, then go here, and then you'll go to all the vertices which may be there. Correct? So totally, let's say there are n vertices, right? Now if it's a hexagon, n is going to be 6, if it's quadrilateral, n is going to be 4, and so on. So now the number of non-overlapping triangles you will get is n minus 2. convince yourself of this. Let me give you some more examples. Here we have 4 vertices. Start from any vertex, right? Leave 2 sides, 1 and 2. That means leaving 1 vertex, is it not? And then join. So you get 2. So when you had 4, you got 2 non-overlapping triangles. Now you take a pentagon. Now start from the first one vertex, leave 2 sides or 1 vertex, and then you get how many? 3. So when you had 5, you got 3 non-overlapping triangles. Now take a hexagon. Again, start from 1 vertex, leave the other vertex, which would mean leaving 2 sides, make the triangles. You'll get 4 non-overlapping triangles. So when you get 6, you get 4. Now see the pattern: 4, 2, 5, 3, 6, 4. So always 2 less than the number of vertices. So if there are n vertices, you'll get n minus 2 non-overlapping triangles. Therefore, the sum of all interior angles, is going to be n minus 2 into 180. Okay, so that's a general concept, a very simple concept. It is not going to get you any marks immediately, but this is something which you should remember. It will make your life quite easy. There is another way also to do this. Let me just mention that to you. Let's say there is a pentagon. Now just take some point in the middle, any point, and just join all the vertices. So now you'll get 1, 2, 3, 4, 5 triangles. So 1 triangle for every side that you have. Now if you leave all these angles, right? If you leave all these angles, then the remaining angles, this one, all these remaining angles become nothing but the sum of interior angles. Is it not? So now, how many triangles do we have here? 5. What is the sum of all the angles? 5 into 180. From that, we are removing how much? 360. So that will give you the sum of all the angles in a pentagon. In a similar vein, now suppose you had n particular sides. So now consider a polygon with n different vertices. So I'm just showing 3 or 4 of them. Now take a point in the center, start making the triangles, and obviously you'll get n triangles. So what will be the sum of all the angles of the triangle? N into 180. From that you'll remove all the central angles, that is minus 360. And this will become the sum of all internal angles. Okay, I'm representing them with only I. So from here, if you take 180 common, you'll get 180 into n minus 2 again. So this is the basic concept. Note this down.